What's up, knife freaks, sharpness geeks, and purveyors of stabby goodness? Welcome to the Knife Freak Show. My name is Jonathan McNees. This is my co-host, Mr. Chase Boatwright.
Welcome to the show, everybody. How you doing?
Doing good today. How about you?
I'm making it. I've been building a fence for chickens and weed eating my entire yard because my lawnmower's broken and something had to be done. Yeah, it's great.
That's no fun. Not as
Yeah,
hot as it is right now, especially.
Yeah, I tried to do it most of this morning and get back in here and get cleaned up before this. So, but yeah,
Good
how
deal.
you been?
I've been good. Some of you may have seen on that I posted on social media. Amy and I were out of the shop on a little vacation this past week, so I've been pretty good.
And why were you on vacation? Why were you on vacation?
Why was I on vacation?
Mm-hmm.
I know what you're getting. I was about to say just because I need a vacation every now and then. But I think what Chase is getting at, it was my birthday this past week. So usually it falls in July, which is kind of vacation time. So we typically end up doing vacation for the week of my birthday. So I get spoiled because I get a vacation every year for my birthday pretty much. So yeah, 1 year older.
Yeah. 1 year older. Hey, that's all we can hope for is staying on this side of the dirt and having another birthday.
Still here, still hanging in here. So yeah. So, and I do appreciate a lot of you did. I saw when Amy did a birthday post or whatever. So, and I saw a lot of you got on there and wished me happy birthday. So I greatly appreciate that, guys. That's always nice to see.
Yeah, for sure.
So my week was fairly uneventful as far as anything work related. How was your week?
Oh, it was good. Good. I finished up, I don't know, 4 or 5, something like that, knives this week for the Mark's Outdoors show that I'm going to next weekend. So mostly fixed blades still. Just that show, I typically take more fixed blades. It's more of a outdoorsy sort of crowd, I guess, that goes there. So I mostly take a lot of fixed blades and a few folders. And so, yeah, I've just been trying to get done with that or trying to, keep the stockpile going with that, and not much else. Just average, week in the shop in July, hot and sweaty and gross, and yeah. Although there was one thing I did for the for those that watch our YouTube channel, I started another build along sort of thing. I need to actually get the first build along all edited together, but yeah, I started a little one-off Warncliffe is what I'm going with as far as the title of it. Took a blank that's been sitting in my shop for 2-3 years maybe, and it's been heat treated and sitting there, and I just hadn't done anything with it. And I've sort of threw up a video of me modifying it, getting to a different shape, and we're gonna do a little build along, I guess, on the channel.
I like it.
Yeah. Back to that, what we talked about last week of adding some diversity to our content and doing some little more technical how-to stuff. You get to see me in the shop grinding stuff and jabbering at the camera at the very least.
Yeah. And we're going to try to do some here at the shop as well. We were just talking before we started the podcast about stuff, cameras and assorted stuff. Going to try to get some stuff going here where we can get some good visual footage for you guys to go along, those of you that like to follow along on YouTube. So
yeah, that's the hardest part I've found is just trying to find places, because I'm not using a camera and just using my phone and trying to find a way to set it up and actually be able to see the stuff and, have the lighting be good, which there was a lot of lens flare on the last video I didn't realize, but yeah. So it's one of those things that we'll hopefully get better at.
Yeah, it's very much a challenge to try to just like self-film, especially just using your phone. And it's tough. It's tough to try to get stuff situated in the right spot. And anyway, it's aggravating. We tried multiple different methods in the past and nothing ever worked great for me, but we're going to get it figured out.
Yeah, for sure. It's one of those ever constant battles. You always try to, improve in every aspect, and that's just another one of those aspects that's part of the game. Like we talk about,
That's right.
Trying to capture, what's going on inside and, put it out there so people can see is just as integral as making the product these days.
Yeah, It really is. It really is. It's an art form in and of itself of being able to put out good content, basically. Like that's kind of its own art form. So trying to combine that with, that's kind of has to be secondary for us. We've got to be able to do our primary thing first, or else the secondary thing doesn't really matter.
Yep, indeed.
If we can't make a knife correctly or whatever, then there's no sense in filming it and then showing a fail or whatever. So nothing's wrong with showing fails here and there, but like we need to at least be able to do what we're supposed to be doing.
Yeah,
so
that's what keeps the wheels moving.
That's right. Yeah, we're not raking in the dough over here on the content, so we still got to sell knives. So
yeah.
But
I did want to mention that we did lose a member of the community this past week as well. Ryan Thompson from UltiClip passed away on July 7th, and I believe you knew him more than I did. I believe I met him maybe, but
yeah, he was a really good dude. I didn't know him well, but we definitely had talked, communicated and stuff from the business we'd done at UltiClip and stuff. So in the past, and yeah, just a really nice guy, like always super nice and friendly to talk to, and from all accounts, just a really good guy all the way around. I know he did a lot of mission work and stuff like that with his church. So I think he was just a really good, solid dude. So we're definitely worse off for having lost him out of the community, but our condolences to his family and stuff, and to his work family there at UltiClip. We really hated to hear that.
Yeah, indeed. It's never fun to hear that kind of news, but it happens. It's unfortunate.
It is.
All right. Well, moving on from that, unfortunately, the unfortunate passing, but we had a suggestion from a listener this past week for a episode, and it was from Mr. Tom Cook, and he wanted to hear about how we dial in detents and how we configure the lock interface on folders, specifically, like talking about from the lock bar to the tang. And so wanted to kind of dive into that a little bit. Do you want to start on locks or detents?
Let's do detents.
All right. Detents. That is the mechanism by which the folding knife stays closed for the most part, requiring enough tension to keep it closed, but not too much tension where it is difficult to open. Don't know why I had to go into like the Oxford Dictionary version of it, but that's where my brain went. So here we are.
That's a good place to start.
Yeah, fair enough. I mean, yeah, I've got some so. First thing with a detent is it's a bit subjective, but there, like I said, it needs to be able to keep the blade in the knife. I think is its primary function. That's the whole reason it exists. And specifically, as far as how it does that on a frame lock or a liner lock, whatever ball detent mechanism, not talking about like an axis lock or any of those.
Yeah, this is pretty much strictly for frame locks and liner locks.
Yeah.
They're pretty much the only main ones, at least, that utilize a detent for the closed position.
Yeah. But, there's a ball that falls into a hole in the blade. The ball is in the lock bar, and the ball falls into a hole that is in the blade. And typically, what you want for good detent is the only contact you really want for that ball to be making is on the very bottom part of the hole where that track rides up into it. You want that little bottom, that infinitesimally small surface of a ball making contact, because it's a sphere. It has like a very, very small point of contact, but just basically where that little trail rides up into that hole, you want that ball to be making contact. And how much that ball is making contact, how far it's falling into the hole, how much lock pressure you have, all of those things kind of determine how stiff the detent is.
And so there's like at least 3 different factors that affect the strength of the detent, and we'll get into the strength of the detent stuff a little more in a minute, because that, when you're talking about subjective, that's where it gets really subjective.
Oh, yeah.
So what Chase is kind of describing is basically as the ball. So picture the ball, the blade is closing, right, and there's a hole at a specific point in the blade, and as the blade is closing, the detent ball is riding on the tang of the blade, and so at some point, what you want is ideally as the blade reaches the point where it rests against the stop pin, so it's in its closed position, like fully resting against the stop pin so that it can't go any farther. And right at that exact moment as it rests against the stop pin, you want the ball to be just falling into the hole enough that it is grabbing that edge of the hole and keeping it pulled downward, if that makes sense. It's a little bit hard to describe.
Yeah.
Without using visual aids, which I think Chase has got some. But so those of you that are listening to this may be a good episode to switch over and go watch it on YouTube so you can see a little bit more of what we're talking about. But you really only want, so what you do not want is for the ball to land like directly centered in the hole, because if you do that, you're going to have lash. I guess probably it's possible to make it do that without having lash if you have the hole the exact perfect size. In theory.
I think, or if you have an undersized hole or oversized ball and kind of do that,
right.
like where it just it's kind of touching on all sides, I think that would work.
But that gets really, really difficult to do without having, because if it's touching on more than one side, then if it's touching on the other side of the ball, it may actually be holding the blade up off the stop pin a little bit. That's really, really easy to do if you allow it to touch anywhere but the leading edge of the hole. So as the hole is coming around, it's moving in a circular motion because the blade is rotating into the handle, right? So it's moving in a circular motion. So as it rotates down, the edge of that hole gets to the ball is technically stationary and the hole is moving. So as the hole gets to the ball, right as the blade makes contact with the stop pin where it should naturally stop anyway, you want the edge of that ball falling over in the hole so that it's like creating a pull against the side of the hole. That's the other thing about not having it centered, is you actually want it slightly off center so that it's creating tension against it. You don't just want it falling in there. You want it actually like creating tension against that front wall of the hole. So, and guys, the stuff we're talking about here, we're talking about most people, not everybody, but I know us, we use 1/16 inch balls. So like that is a very small ceramic ball, and then the corresponding hole, we actually make the holes bigger than a 1/16 of an inch. Mm-hmm. So like I said, I prefer to have clearance around the rest of the hole so that it only touches on that leading edge where we want it to be touching and pulling against it. You're just way less likely to run into issues where it might be holding it up off the stop pin or something that way.
Yeah, and if it's like he's saying, if it's being held up off the stop pin, that's when you get lash, like where you can pull on the blade and you can feel the ball kind of moving around in the hole. It's not, like it's not fully seated against the stop pin. It's got some wiggle room.
You can. Yeah, sorry to interrupt. You kind of, so what I technically call lash is when the ball is in the hole, but then you can pull up on it, and there's actual, like, now especially if you have a strong detent, you can pull on the blade like you're going to open the blade, and you can feel a little bit of movement. But if you watch close, what you'll see is that the lock bar is actually flexing because that ball is gripping in the hole enough that it's actually pulling up on the lock bar, and it's actually flexing a little bit. And then if you pull enough, the ball will pop out of the hole and then it opens up. That is not lash. No. Lash is if you pull up on the blade and there's like some dead space there, whereas you pull up on the blade, it's not being held tight against the edge of the hole, and it moves some, and then you can feel it hit the edge of the hole, and then the ball will pop out of the hole. So like there's some space there between where the detent ball is not resting solidly against the edge of the hole, and you have to pull the blade a little bit before you feel it make contact.
Yep.
You can have a blade, like you said earlier, if you have a hole that is maybe undersized from the ball or even the same size as the ball, you could technically have it resting in the hole and not have any lash as you pull upward on it. So it could be still hugging that proper side of the hole or whatever.
Yeah.
But basically it would be making contact around the entire hole. So like the ball is fit down in the hole, like it's not just touching one side, it's touching essentially the entire diameter of the hole simultaneously, right? And so if it's doing that, and it's doing that a little bit too high so that you're not resting good on the stop pin, you might not actually feel that space there as you pull up on the blade, like to open it. But if you press down on the blade, there's going to be movement as it goes down and touches the stop pin because it's being held off of and that may technically be called lash too. I don't really call that. We call it bounce just to make it clear what's going on. So,
differentiate the problem.
That's right. And now I will say this too, before all you guys get all your knives out and start messing with them. Any knife, pretty much any knife that's even is totally, the detent is perfectly correct. If you take and push hard enough on the blade in the closed position, like downward, you're going to have some flex and you're going to see it move. So I'm like, very rarely you're going to see one that's like just like you can't squeeze it hard enough to make it move. Almost all of them, you can flex a little bit of movement in there, kind of like we were talking about the lock bar flexing. That's not the same thing as actually having bounce there. If you ever feel it, and it's not a common problem that I've seen, but you can kind of tell the difference if you're feeling it. Like you can tell that it's like pushing down and then like making solid contact with the lock bar, not just that it's flexing. Like there's like a noticeable like movement and then contact versus
it's almost a click too usually.
Yeah, right.
Like
it almost creates like a clicking feeling
because it's popping up out of the ball, out of the hole on the wrong way, basically, like and going too far down.
That's right. Yeah, it's popping out of the other side of the hole.
Yeah.
So but like you can feel the difference very much so between flex and actual like bounce or lash. Like it's a pretty noticeable. Usually the biggest difference you feel is that there's like a kind of a hard wall or a stopping point, or whatever. Like I said, with lash, if you're moving it, you feel the blade move, and then you feel the detent ball hit the edge of the hole, and there's a gap there in between those, the start of the movement and the ball hitting the hole.
Yeah.
And then if you're feeling of it for bounce, so you usually can tell that it's there's movement there before it actually makes solid contact with the stop pin, and then it kind of lifts it back up off the stop pin. And like I said, that one I feel like is fairly rare. At least I've never noticed it very much.
Yeah.
So
with all that, I guess being said, like I know how y'all used to do it. I don't know how y'all do it now, but I guess I still do it how y'all used to do it as far as dialing in detents. How do y'all dial in detents these days?
All right, so it all starts with us, and we can go back to I'm assuming you still do it the way that I did it when I did handmade, right?
Yeah.
So we'll let you get into that in a second then. So what we do, since we're doing it, since the detent hole's been put in on the CNC for us, we're not doing it manually. So I've located on the, in my 3D model, I have a hole, or actually typically I honestly just do a point. Sometimes I model in the hole, but there's no really need to. So there's a point on the blade in my drawing, in my 3D model, where, it needs to be aligned in the same arc, in the same radius as the blade is moving. So it needs to be, because if you took that detent ball, the detent ball will actually kind of scribe a track on the blade. Like you'll be able to see where it's been riding on the blade. For those of you that are taking your knives apart, you know what we're talking about. You can see where the detent ball rides. So if you took the stop pin out or something, like if you took the blade and made a complete 360 degree around and around with it, the detent ball would scribe a circle, a pretty close to a perfect circle all the way around the pivot hole, right? So it's rotating around the pivot. So the detent ball is creating a circle that is a perfect circle at the same starting point as the pivot hole. Sorry, because that's what it's rotating around, right? So it has to be lined up in that same, you have to know how far your detent ball, wherever you put your detent ball in your handle is, then so that distance away from the pivot, the hole has to be that same distance away from the pivot in the blade, so that it's in that same diameter. So if you think about like circles you have a circle and then you have a bigger circle outside of it and a bigger circle outside of it, but they're all have the same center point, right?
Yeah.
So you have to have the circle that your detent is going to fall in has to be the exact distance that your detent ball is from the pivot. And then it has to be in the right place in the rotation. And that is, I typically do it like in my 3D model. I have it at the blade in the closed position, and then wherever I've got the detent ball modeled in, the hole for it is modeled in. And so in the center of that hole in the closed position, when it's resting perfectly against the stop pin, I put a point, but then I rotate it slightly up away from that point by, I don't know, it's never perfect to start with, but it's probably like a, I don't know, 0.3 of a degree, something like that. When you deal with rotation like this, a degree is a lot.
Yeah.
Like a lot. So it's like fraction of a degree that it's rotated up, so that, because like we said, we don't want the ball and the hole being perfectly centered on each other. We want the hole to be slightly offset. So does that, and then honestly, like if it's on a like a new design or whatever, then we run several of them and put them in the handle and see how they fit, and then adjust it either farther up or farther down, staying in that same arc, that same radius around the hole. It moves in an arc. It stays in that circle, but it either moves farther away from the ball, the point of the ball, or closer to the point of the ball, depending on which way it needs to go. So then the machine puts a hole there in the blade. All right, so it comes off the machine. But we always, because things happen, especially because we're dealing with, then the blades are getting these holes put in them, and then they go get heat treated. And especially with MagnaCut, because it moves more than most steels when you heat treat it. Stuff tends to move around and stuff. It tends to grow, or usually grow, not sometimes shrink, but usually it grows.
Yeah.
So instead of trying to get them to be exactly perfect every time, because what happens without fail, if I could locate the detent hole exactly where I wanted it, so the detent would be basically perfect, and we send a batch off to heat treat, they are not going to come back landing in the exact same place, because again, stuff moves and grows when you heat treat it.
Yep.
So what we do is we stop them a little bit short, so that typically a blade that's ready to be put together, you put it in the knife, and typically the detent is not falling in the hole. The ball's not falling in the hole quite as much as it needs to, because it is way easier to remove more material out of that hole and get it to fall in the hole than it is to try. You can't add material back. So I would much rather it stop a little short and then us have to adjust it. And we try to ride the line really close, so that sometimes we get lucky and a certain percentage of them come back from heat treat and they're fine. Like we don't have to do anything to adjust them. Yeah. But the ones that we do, essentially we have a bunch of different little drill bits that get bigger incrementally, so that, and we got like 2 or 3 little miniature drill presses sitting on the bench there where the guys work that are fitting them up. And if the detent's a little weak, which means that the ball is not falling in the hole enough, then they start with the smallest size drill bit that's just basically is slightly bigger than the hole that's already in there. And they open the hole up a little bit, check it. If it's falling in there the proper amount, then good to go. If not, we step up to the next size. And typically now we've got it dialed pretty good, where it's usually no more than like 2 different size drill bits at the most. It's usually that if the first one doesn't get it, the second one usually does. We have some percentage that are good without anything, and then most of them are going to be good with drilling them out one time with that next step, and then every now and then one will be aggravating, and we'll have to drill it out one size bigger or whatever. Yeah. So we're literally hand tuning each one to fall in the hole the amount that we want it to. And then sometimes it's so slight that honestly they're not even drilling it. They're taking we've got little Dremels at the station out there with a little carbide burr in it, and sometimes they're just very lightly hitting the edge of the hole with that to just it's such a slight amount of material that needs to be removed, that it's just a little kissing it with that burr is enough to make it drop in there the extra amount. Like, it's hard to describe how small the tolerances are for this, guys, because like I said, you're dealing with rotation, so it's say a thousandth is a huge amount when it comes to rotation. If you move something a thousandth in a circle, in a rotation, that is a lot. So anyway, it's very, very, very minute amounts of adjustment. And so that's what they get. And basically it goes by feel, because maybe somebody, way smarter than me has come up with a good way to actually measure detent strength. But for us, it's all by feel, which is also part of the reason why you may pick up 5 of our knives and a couple of them may feel just slightly stronger or lighter on the detent. It's done by feel. That, and we have to have a range. There's no way to get them all that let me not say that there's no way, because there may be somebody out there that has the advanced enough processes that they are getting them super, super, super close on every single one. But for us, we have not gotten to the point where they're all going to feel exactly the same.
Yeah.
We stay within a range, an acceptable range. One of the things we look for is once the blade is in there, can you turn the knife over and like holding it by the handle, can you shake it out easily? That's not to say can you shake it out at all. But I'm going to tell you guys a quick little funny story here. You won't put Chase in the spotlight, but I'll say this: it happened first with Chase because he was the first one I taught to do detents on the Mac 2s. But it's happened with basically every single person that we've taught to do it since then too. So it's not just Chase. So I teach Chase to do these things. I teach him to do the detent balls. I just I say, okay, now you got to make it tight enough so that when you turn it over and you kind of shake the knife like this, that the blade doesn't pop out. Okay. And so he goes to town. Huh?
And hold my beer. I got this.
So he goes to town working on them, and I don't remember the time frame, if this was just like later on in that same batch or
I
what.
think it was progressive, like it moved like a couple batches down the line. I just kind of kept getting further and further.
Right, because I feel like we started getting a couple of reports back that the detents were too strong, and I was like, well, and I checked them, and like sure enough, yeah, they're too strong. And so, and if they're too strong for me, then they're definitely too strong. And so I was like, all right, show me what you're doing or whatever. And he was like, well, I'm doing this. You told me to make them they don't shake out. And I was like, all right, well, test one. And he tests one, and he's over the couple of weeks there of doing these detents, he's developed this like super snap where he's like taking the knife and like cracking it like a whip almost. And like, of course, the detent would have to be like just unbelievably strong to hold the blade in there with it being snapped like that. And I'm like, okay, I see the problem here. I was like, the blade still has to come out, but let's not do it with a super snap there. Let's just do it with kind of a normal amount of shaking. And as crazy as that sounds, that we have had to have that. Every single person that's learned to do detents has had to go through that same evolution.
I think it's just because like you're sitting there doing them one after another, and you don't know like how hard you're shaking. Like I don't know, you kind of get maybe one's frustrating you, and you're like are you why aren't you working? And I think it just progresses to the point where I don't know, but yeah, that is
and I think you get a little paranoid. It's like okay, that one popped out one time, but did I shake it a little hard on that one shake, or is it actually too weak? And then it just kind of I think it just, like you said, it just kind of slowly progresses, and people start off good, and then they get more aggressive with it, and before you know, they're over there popping them like a whip, and of course the blade is snapping out then. And it's like, if you make it strong enough that it won't come out with that, nobody's going to be able to open it, with their thumb. So
yeah. So if any of you have the early Mac 2s and have shredded thumbs, I apologize, but that was my bad.
Yeah, but
I had shredded thumbs too.
That's kind of and again, it goes back to not having, and again, we may at some point come up with a good, like, scientific way to test them. I've played around with some ideas and really haven't come up with anything good and consistent, but it's, a lot of it is by feel. And so, turning over and shaking it and making sure the blade doesn't come out too easily, that's kind of the base test of, is it strong enough? And then, obviously we're just flipping them open to check and see how strong they are and make sure they're not too strong. The problem you run into with that is kind of like you said, like you get somebody that's sitting there doing that all day, every day. Well, their number one, their technique is way better than somebody that's not used to opening one of our knives. Yeah. And number two, like their thumb and everything literally gets tougher and stronger from doing it all day, every day. And so what feels fine to them may be too hard to somebody else that's, maybe new to our knives, or just maybe, doesn't have very tough or strong thumbs or whatever. So it's kind of it can be a little bit difficult to find the balance of, okay, where's the sweet spot for this? And then you add on top of that, you get complete and total subjective opinions from customers too, because what one person thinks is way too strong, the next customer loves. Yeah. So it's, you can't make it just one perfect thing for everybody, because all the customers have different opinions on what's just right too. So
some people want it to roll out like an art folder, and others want it to snap. So it's all about personal preference really, and we're just doing our best here.
Yeah. Well, and for us, we, as most of you probably know that own our stuff or have handled it, for the most part, we, again, we can't make them all exactly the same if we wanted to, but I believe in a good, strong, snappy detent because I designed these knives from the get go to be flicked out, not to be necessarily. It's fine if you want to roll them out, but that's not really what they're designed for. Like they're designed to be flicked out. That's everything about the way we make them is kind of revolves around that. So that's just I I made a lot of flippers as in the custom world, and that making the detent and with a flipper, it's in my mind for a flipper to be correct. Anyway, I've handled a bunch they're technically flippers, but they're not correct. For a flipper to work correct, you should be applying pressure to the flipper tab, and it basically build up pressure because it's being held closed. And then when that ball finally releases, it has all that kinetic energy built up, and it basically just flies out of the handle. So that's the same principle that I go by with thumb studs or thumb holes too. That's the way I like for mine to open. So, but I've also been flicking knives open with my thumb like that since like the late '90s, so probably mid '90s. So, you know, it is what it is. That's just the way I like to do them. So it's the way I like to open my knives. So it's the way I build them. And so anyway, but not to go too far down that. But that kind of explains what we're going for. But now Chase's method of doing it is he's trying to accomplish the same thing.
Yeah.
It's just that he's not being able to just. Whoa! I'm about to kill my microphone. Hold up. All right. So he's trying to accomplish the same thing, but he can't just go into a 3D model on his, in Fusion 360 and put a hole and then
I mean, I can,
drill
but
it there. You can, but
yeah,
you still got to.
I can't read G code, and I'm not robotic like that, so it doesn't help.
Well, I
me
mean,
much.
you could technically, I guess, probably make you could print out
probably.
If you really wanted to try, but even then it would be good because again, the tolerances on these are so slight that even if he like printed out a pattern, like say he printed out his design on in full 1-to-1 scale on a piece of paper and glued that onto a template and then put that template on the steel and drilled through that spot that he had on there from Fusion.
Yeah.
The chances of hitting that spot perfectly enough drilling it by hand are like.
Yeah. Especially with these very, very small drill bits, they do like to wander and walk, and they bend and flex. And because, I mean, we're dealing with, I don't know what a 55 or a 53 drill bit is, but it's very, very small.
Well, it's smaller than a 1/16 of an inch.
Yeah.
The ball is a 1/16 of an inch. So it's like, I think a 55 is like 0.059 or something like that. I don't know. Don't quote me on that. But
like
they're
0.59. Yeah.
Yeah, 0.59. Yeah.
Yeah.
So anyway, we're talking about really small tooling rivers. So anyway, it's not really practical to try to just like drill off of a template for what Chase is doing. So I'm going to let him explain how he does it to make it work with the handmade stuff.
Yeah. So, like you said, I'm pretty much trying to accomplish the same thing, still the ball falling in and basically just touching the bottom part of the hole. But how I get there to actually putting the hole in the blade is after it's heat treated. I've already done all the other stuff. I do this like right after I get done setting the lock, which we'll talk about momentarily. But I put the detent hole in the frame, in the lock bar, and leave it open. I figure out where the track will be best, I guess, in that radius and what will, not go too far outside of the handle and will not fall off the blade and, all that. And I put that hole in the titanium. And then from there, I take the knife, basically assemble it. It's all, sort of raw parts at this point. Usually the blade's not even ground. And then I take it all, assemble it, full backspacer, standoffs, stop pin. Very important to have a stop pin. I went to go try to drill a detent without a stop pin before. Didn't make it very far. But it needs to be resting against the stop pin in the closed position. And what I do from there is I clamp the blade. That way it is exerting pressure down onto the stop pin as far as like in, pulling itself closed.
You're
And from
flexing
there,
it like I was describing earlier. You're
flexing it.
intentionally flexing it beyond the point that it naturally rests on the stop pin.
Yes. And what that does is basically create that offset that we were talking about, that little bit of, instead of just drilling straight through this hole that I've already put in the titanium and into the blade and, creating a 1-to-1, this hole lines up with this hole, creating a little bit of offset and, moving where that hole was going to land. And so I clamp it, and then I take a carbide drill through the titanium that's on, like, from the outside, put the drill bit through the titanium hole and into the blade. Basically, I just spot it from there and then take the blade out and drill it. And then from there, I'll bend the lock bar if I haven't already bent it already. Sometimes I bend it beforehand, sometimes I don't. I don't know. But then I put a detent ball in, do all that, and check the detent. Most of the time these days, I'm good there at just wherever I've kind of gotten to the point where I'm pretty dialed in. I just have to do it that one time, and it's usually landing in the hole good. If not, I basically do the same exact process that Jonathan described. I open it up a little bit to the next size, or if it's only a little bit, I too have a little Dremel tool. I don't have a fancy Fordham, but basically just a little Dremel carbide bit, and just ever so slightly bump that bottom, that very tiny point where the detent ball is falling into the hole. And that's how I do it. And there's a little bit in there as far as lock bar pressure, but for the most part, I try to I try to just set the lock with the proper amount of lock bar pressure where it's not too hard, not too loose, and, not too stiff, not too loose, and try to just let the detent fall in sort of naturally, more so than trying to adjust it with the lock bar.
Yeah. And what, just to make it a little easier for people to picture what Chase is talking about. So he's already got the hole pre-drilled through the lock bar, through the titanium. So when he's got the blade in the handle, he's got the clamp on the blade, flexing it so that the hole is through the titanium, so you can literally look through there and see, and that spot that's underneath that hole on the blade is above where it would be if the blade wasn't flexed farther. So that's what's causing it to be offset. But then he's just taking the drill, and essentially the hole through the titanium is like a guide. He's just, he's not actually re-drilling the titanium. The drill bit that's the same size drill that he already drilled through with the titanium.
Yep.
He's just using that hole as a guide. So the drill bit just runs down through there, and then he spots the hole in the blade. And then when he takes the blade out and drills it, and the reason it's important to take the blade out and drill it is because, like he described, those little drill bits, when you go to drill with them, especially when you're trying to drill into hardened steel, they have a tendency to flex. When they flex, they start wobbling, and if you guys can't see me on YouTube, it's kind of hard to explain. But the blade, the drill bit will kind of do this number. Mm-hmm. It'll start to bow out in the middle, and so if you have that drill bit through that hole in the titanium while you're trying to drill through into the blade, and it's wobbling like that, well, you're basically just opening up, as us down here in the South call it, you're wallering out that hole.
Yeah, right? I was about to say wallering out.
Yeah, you're wallering the hole out. It's basically opening up that hole because the drill bit in where it's through the titanium is doing that little wobble dance on you, and so it's essentially like drilling it with a bigger drill bit.
And that means your detent ball ain't gonna fit.
Right, and now the detent ball is not going to stay in the hole because you've just wallered your hole out. So that's another one of the little small details that are key to not messing up on that. And like for us, we actually now on the machines we drill the detent through the titanium. So the hole that we make to press the ball into, it gets drilled on our second operation, which is the outside of the handle. But we do it like that so that by the time, if that drill bit wobbles, it's wobbling like in like the center of the lock bar, so that by the time the drill pokes out of the bottom, the tip is where it's going to wobble the least. So basically the tip is just, when we're drilling from the outside in, then it's only the tip is breaking through, and there's really not that much wobble there. So we get a more true sized hole for the ball to go in, so that it's not as likely to pop out. Right.
Yeah.
So,
and I kind of do similar operation where I drill it with a smaller size from the outside for the first step like you taught me, and then I go back, I take the knife apart and I flip it to the inside and I drill it with the proper size, so that way it remains more true to the detent ball size at the point where the detent ball is going to be resting.
Because that first, just say 16th inches, so the ball is 1/16 of an inch, and we're going to about to get into a couple of other factors that have to do with the detent here, but it's going to get pressed a little over halfway into the hole as far as depth wise. So you need at least a 32nd, might as well say a full 16th of that hole on that inside being as perfect as possible, like the perfect diameter as possible, so that it fits correctly with your detent ball, and the detent ball presses in there and stays in there correctly. So.
Yeah, that was a factor I hadn't even thought about until you just brought it up, was the depth of the detent ball and how much is actually sticking up out of the,
That's one of the three big factors. Yeah, for a detent. So
I guess I don't think about it as much because I just do it the same every time. I don't really mix it up. Like I know other people will do it depending on if they're making a thumb stud versus a flipper or whatever, but I just do it the same every time and just set it like that. So
and so on that note, so the other we've already mentioned both of the other factors, but to just go into a little bit more detail on them. So the height of the detent ball makes a difference, but we don't really try to adjust the detent. Like we strive to have the detent balls the same height on every one. Like we're not trying to like make adjustments off of that.
Yeah.
Every now and then, if for some reason the detent ball maybe didn't quite get pressed, like it's on the high side of being okay, and the detent's still a little strong, and then we might press it in just a little bit deeper or whatever.
Yeah.
But let me say this, guys: do not try to press in your detent ball to make your detent weaker on a knife. Almost 100% chance you're going to give the knife lash.
Yep.
And then if you go too far, you're going to end up trying to get pop it back out, and you're going to end up popping your detent ball out. Trust me, it happens. And it may sound like some of you may be thinking, well, I can't believe surely nobody does that. Yes, they do.
Oh yeah.
Yes, they do. I've actually had a dealer ask me, was it okay if they like adjusted the detent ball, and I almost had a freaking heart attack. I was like, no, do not touch our detent balls. If you think it's too strong,
don't touch my balls.
Don't touch my balls, man. Don't be trying to press my balls deeper. They're good. If they need pressed, I'll press them. So, well, that took a turn, didn't it?
Yeah, I need a minute.
So, yes. So, even though that we're telling you that that's, behind the scenes, that is a way, but again, we only do that if we look at it and we can tell that the detent ball is higher than it should be.
Well, I mean, because you're dealing with a sphere, if you raise or lower that, how much is in, sticking out, you are changing the amount of material sticking out as well, because if you push it down further in, you effectively have a smaller circle.
Right, exactly.
Falling into the detent.
The diameter of the part that's sticking out is going to be smaller.
Yes.
And you have to, when you press the detent ball in, it needs to be at least, we go for just slightly more than half of the ball sunk into the hole.
Yep.
If you have less than the ball, you imagine a spear, you've got a ring around the outside of it that's clamped onto it, holding it. Well, if you're below the apex of the ball, then it's going to be more likely that it's going to like slide out, because you're gripping that bottom spherical portion, if that makes sense. Where's Bill Nye when you need him? Holy crap. So you need to have it at least halfway, maybe just slightly more than halfway in the hole to start with. And like I said, when we set detent balls, we're not using those thinking, oh, we'll just adjust the detent with that. The only time we do that is if we've done everything else we can to make it, and it's still a little bit strong, and we look at it and we decide that the detent ball is higher than it was supposed to be in the first place, then we bring it down to bring it to the standard it's supposed to be at. That is not a method for after the fact for trying to tune the detent and make little small adjustments like that. That's a horrible idea.
Definitely.
So
the only knives I know of that do that are actually some of the ones I'm holding. I'm holding an old Ferrum Forge. They use a Hoback rolling detent, where it's basically a detent ball on a lead screw, and uses that method. But that's not anything I've ever done with as a maker. So
no, and I don't think that that's even close to being a good way to adjust the detent. It's just not, because again, you're not just you can't do that without changing, like you said, the diameter of the portion of the ball that's in the hole. And there's such a fine line there between, making it a little bit weaker and causing lash that, like, I think that's a horrible way to adjust the detent strength. But that being said, then just so we give you the whole process. So what we do to press the detent balls is when they come off the mill and everything, that's they get some cleanup and stuff, deburred and that kind of stuff. And then they get taken over there to an arbor press. And we actually have a hardened steel rod that we drilled a little dimple of a specific depth into. That's actually, so the dimple is slightly, let me think about this, make sure I don't say it in reverse here. It is slightly shallower, it's slightly less than the diameter of the detent ball.
Yeah.
No, slightly less than half the diameter. So slightly less than the radius.
Yeah, you've got a little more than half sticking out after the dimple is applied to it.
Right. So what the dimple does, so you take the knife handle, it's got the hole in it for the detent ball to go in, take a pair of tweezers, you drop the ball in the hole, and then on that, you're at the arbor press, and you take the little hardened rod that has the dimple in it, you put the dimple on the detent ball, so the detent ball is sitting up in that dimple. But again, the dimple is less than half of the diameter of the ball. So then you take the arbor press and you press it down until the rod bottoms out on the handle, and so that seats the ball at a little over half the depth of the ball, like we were talking about doing. So that's one of those things we may have to share a video of, because it's maybe a little bit difficult to picture describing.
Yeah, that's what I was thinking. And I really need to make a rod like that like y'all have been meaning to for years, but I still use the old feeler gauge and a hardened blade. And
there's other ways to anything that's going to allow it, that's going to kind of create a stop so that you press the detent ball down a known distance. Like you can also use, if you had a washer or a couple of washers, whatever that's like the right size, you could lay a washer so that the ball is on the inside of the hole of the washer, and then when you press down with the ram of the arbor press, it's going to bottom out on the washers, but in the center where the ball is, it's going to have pressed it to that height, the same height as the washers. So like if you had a washer, and he's talking about using like a feeler gauge, which same principle. It's basically a feeler gauge like you use for spark plugs or whatever. And with a hole drilled in it, so it's the right, whichever feeler gauge he's using is the size. That's the
I should depth drill a hole in it.
Huh?
I should drill a hole in it. Yeah. No, mine doesn't have a hole in it. No. I put it right up beside the ball and put the blade, the hardened piece of steel over the top of it. And it works.
I always like to
drill a hole in it.
To drill a hole in it, and so it kind of create. So then you can just lay that up there. You can lay your feeler gauge, drop the detent ball in there, and then when you press down, the ram of the press will bottom out on the gauge or the washer or whatever you're doing, and it will that's the height that it will leave the ball at then. So it's a way to get a reasonably accurate amount. Now that I say reasonably accurate because when you're on an arbor press, you can take two different people pushing, and depending on how much strength you put into it, there's always going to be some flex and stuff. Like you can take with the same washer on there or whatever, and two different people push, or even the same person just would apply different amounts of pressure, and it's going to sink it the slightest bit more, less or more. Yeah. So that's not but we're talking about minute amounts of difference, but it doesn't take much difference on a detent to cause a whole lot of change. So, but that's the basic principle of putting the ball in. And then the third factor that really affects the detent strength is Chase mentioned it a minute ago, and that's the strength of the lock bar. So how much tension the spring has on it. And that actually has a couple of different factors as well, because, and so the lock bar strength, the lock bar is essentially a spring. So the strength of your spring is the other big factor for the detent strength. And so break that down, there's a few factors that affect that. So one being the length of the lock bar. So how long the lock bar is from where the detent ball is to the lock bar relief area, that makes a difference. How far you have the lock bar bent, so how far the spring is bent over, and then the amount of relief, how thin the relief was milled down to. So the little pocket that we all put in and people do it different ways, but the typical is just a pocket that's relieved down, and is fairly thin at the bottom of the pocket. How thin or thick you leave that makes a lot of difference in how strong the spring is. So it's a combination of the length, the thickness of that, and the how far you've bent it over determines, how strong the spring is, and that greatly affects the strength of the detent as well. You're not gonna you can't fix everything with just lock bar pressure one way or the other, less or more, but it is definitely one of the bigger factors. I also do not recommend fooling with this as a customer. I know a lot of people do, but I definitely do not recommend it. For one thing, especially if you mess with it a lot back and forth, and you don't really understand how much pressure it takes to bend it and stuff, and you bend it and then you accidentally overbend it, so then you bend it the other way, maybe you accidentally overbend it that way a little bit, and you kind of keep going back and forth. It is not that difficult to just snap your lock bar completely off.
Nope. I mean, think about like a paper clip for you guys. Like if you just bend it back and forth and back and forth and back and forth, you're going to fatigue that metal, and it becomes a lot easier to snap.
Yeah, and titanium is strong, but it still has the same effect on it.
Yeah,
just
it's not
I know
invulnerable.
I'm bad about, if I've got a nail in something I can't get out, or if I can't pull it out, I'll just bend it back and forth till I can break it off or whatever. I'm sure most of you have done that kind of stuff. Same idea. And like I said, guys, that's just a quick little note on while we're talking about it. Titanium is not nearly as indestructible as a lot of you think. No. It's yes, it's a fantastic material and all, and it is tough and all that good stuff, but it is not the indestructible, whatever.
It's not adamantium.
This ain't what Wolverine's skeleton's made out of here. It actually is, it still has properties that you have to work around.
Yes.
So anyway, that being said, we don't really have a gauge. It's kind of just an eyeball thing on how far we've been the lock bars, but it's kind of in relation to how much the lock bar is bent as far as whether it clears the handle, the frame in front of it. So like where the cut is that, for the lock face, whether or not we bend it past the inside of the handle or not quite, or how much past. And that varies depending on the model and stuff, because again, the lock bar length makes a difference. So for example, we don't have to bend, or we actually can bend the Dixons a little bit further than we can on the Mac 2s, because the lock bar is longer. The shorter they are, the stiffer they are. Yeah. So if you have a shorter lock bar, and say like on a 3-inch Dixon, you can't bend it as far as you could on a Dixon, because it's shorter and stiffer. So
I mean, you can bend it that far, but it's going to be a lot stronger.
It's going to make it a lot harder. Yeah. Right. It's going to be a lot stronger.
I have
so to get
no idea.
The same strength ratio, you have to kind of go by how long the lock bar is and stuff. So
I have no idea how you used to tune and do detents with the killer bees and the tracker jackers with the lock bar that's maybe 1.5 inches.
Yeah,
maybe 2.
It wasn't easy.
Yeah,
which to be fair, the killer bees weren't they were one of the exceptions to one that wasn't necessarily made to flick out, just because.
Yeah.
Even though you still could on most of them, but it's that was a little different scenario with the Dixon and with the detent and stuff. Apparently, I got Dixons on the brain. Surprise. But the little tracker jackers were pretty snappy though. So.
Oh yeah.
Anyway, but yes, that's kind of the main factors. And like I said, let me reiterate this: I highly, highly, highly do not recommend, doing either one of those things. Do not fool, for sure, for 1,000,000% chance, do not fool with the detent ball.
Yeah.
If you think something's off with your detent or whatever that needs to be adjusted, then you for sure need to contact the manufacturer, because you do not need to be fooling with the detent ball. And pretty much the same thing on the lock bar too. I've coached a few people through it, that didn't want to have to send their knife in to, how to just slightly tweak it. But even then, I really don't recommend it.
That's a puckering operation even for me, and
right.
I'm quote unquote a professional. So
well, like I said, it's also super easy to just accidentally bend it a little too much, and now we're back to what we were talking about earlier with the whole blade, trying to shake the blade out, and now your blade just falls out, and so now your only option is to bend it back the other way some. And like you said, you don't have that many times of doing that back and forth before that lock bar is going to be in danger of snapping on you. So, it's just much better to not fool with either one of those things. I know that there's people out there that relay these hacks back and forth between in the groups and stuff about oh, let's do this because we see them like recommended in our in the group or whatever, like, and I'm like, no, I mean, I really don't recommend that. You need to just contact us because you're looking for a problem and you're for sure voiding your warranty on any knife out there if you start taking matters into your own hands with trying to adjust stuff like that. So just that caveat of I hope that you all come to a better understanding of how the detent works out of this discussion, but I don't want you to take that information and screw a knife up because you got overconfident and like, oh, let's say if the detent ball was lower, it'd make the detent weaker, and then all of a sudden your knife either won't stay closed or it has horrible lash or whatever. So just contact the maker if there's an issue.
For sure. So I don't think we're going to be able to cover locks this time, seeming as we're already about to bump an hour, and you didn't think we'd be able to get a full episode out of this topic, did you?
Yeah. I always underestimate my ability to ramble about stuff, apparently.
Yeah. So, yeah, well.
Detents are a pretty, I feel like this, I don't think that the lock one will be a full hour. Like that's.
Yeah, we'll see.
Yeah, we'll see. Maybe. It's just not, I don't know. I don't feel like that it's quite as
detents are harder to explain.
Yeah, they're harder to explain. There's kind of more factors and stuff that go into them in a way. Like there's more stuff that affects it than I feel like than there are the lock. Like the lock's a little more cut and dried to me. But
yeah, I would agree.
See.
All right.
But yes, so, that's the basic idea of how your detents are born.
So now that y'all are all in detention, let's get some questions and see what you guys see what we think about that. Did you like my detention joke?
Yeah, I was drinking water. I almost spit it out.
Oh, nice. All right. So on that note, we had a question about flattened detent balls, yes or no, and that is from Chris HUYNH1. So thank you, Chris, for the question. I don't know if that's no, that was different question. Sorry, never mind. But yeah, thank you, Chris, for the question. And what are your opinions on flattened detent balls?
I definitely not gonna say it's wrong. I know several makers that prefer to do it and swear by it. I've never found it necessary. I don't really see any major advantage to it, and it's I don't know. There may be, again, I'm no Bill Nye here, but like I don't. When you do that, you are creating more surface area that is touching, right? So
yes,
normally when what we're talking about is the ball is riding on when it pops out of the hole, between the hole and the edge of the blade, which is usually somewhere around the lock face of the blade, where the detent ball is going to fall off as the blade is opening, which is typically right at the very end, right before the blade locks open. Typically it falls off the detent ball. So that space where the ball is riding on the thing, you've got ceramic riding on hardened steel, and the ball comes to a point, obviously, however, and for the ones that we're using, they're a small 1/16 inch ball. That's a pretty small, pretty fine point.
Yeah.
So if you flatten it, it's creating more surface area, which in my mind creates more friction. I mean, it has to. Like I do know enough about science to know that if you got more surface area touching this, same surface area on the blade end, but then if you have more surface area of the detent ball rubbing on it, then that creates more friction.
I think the philosophy of it is to spread out the friction is sort of
exactly so that it's not right at. And I will say this, like ceramic detent balls in particular, you really do need to keep just a very light film of lube on them. We've actually started using blade wax instead of oil, but you need something to lubricate them because they can actually get to the point they actually start squeaking. Yeah, and I've had them get to the point where it felt like, the blade was just like super tight and stiff. Like felt like the pivot was way over tightened or something.
Yeah.
But then you put a little tiny drop of oil on that detent track and work it a couple of times, and it's like butter again.
It's so weird.
It is so weird, and it doesn't do it all the time. Like I can't even remember the last time that I've seen one do that in the shop. Like it's, but
it's very rare. Happen.
Yeah, it's rare. So I'm assuming that is kind of what they're trying to get away from by spreading it out over a little larger area so that you don't have such a pinpoint, that, and because ceramic running on hardened steel over and over again, it is going to cut a slight track into that. It's actually digging into the metal some. Like
Yeah.
it's not a lot. It usually kind of reaches a certain point, and that's just kind of it. It's not
Yeah.
like it's just going to keep going all the way through your blade or anything. It's like, I mean, but I'm assuming that that's the thought behind that, is to spread that out so it doesn't cut quite such a track in there, and it spreads it out a little bit. Probably
Well, I
makes it a
think,
little easier to lubricate.
yeah, but I think once it, creates a little track, I mean, microscopically, I would assume that has to be a tiny little bowl, thereby spreading out the friction and it making more points of contact, in that way as well, once it breaks in.
Yeah, yeah.
But yeah, I
Which I've
mean,
never really had a problem with it. I mean, it creating the track is just normal. That's
yeah,
and in fact, if anything, once it's kind of gotten down to the depth it's going to do, is you're essentially like just polishing it over and over by
yeah,
burnishing it. So I mean, I feel like it's actually a good thing that it does that. So it's
yeah. I mean,
but
that's all of what Jonathan said is basically my opinion too. I don't see the need to do it. I understand. I mean, I've heard, I think it was John Grimsmo talked about like rubbing, your finger point across a table versus rubbing your hand across a table and seeing what, kind of feels smoother. And that's sort of the idea of kind of spreading out that point of friction. But I really don't think it's a necessary thing. I think it will, the knife will break in, especially using ceramic. I don't know of any, like, I don't know if they flatten ceramic detent balls or if they use steel or
yeah,
not.
I'm
But
not sure. I think they must, because most of the people that I feel like the majority of people use ceramic at this point, but
that's what I feel
I
like
could be
too. But
wrong.
I don't know.
Yeah. I don't know. They may be completely right. I think probably the main place you might feel it is right just during the very initial, you know, break in period or whatever.
Yeah,
Like I just don't feel like a knife that's been opened very much that you're going to be able to tell much difference in it. And I mean, in my mind, I feel like, less friction is a good thing typically. So like if you're wanting something to move smoothly, I mean, you think about anything else with moving parts. I mean, typically you're trying to do everything you can to reduce friction.
yeah,
So in my mind, sticking with you know, a non-flattened ball that has technically less friction is a better way to go. So,
yeah,
but I don't I don't have any great science to back that up other than the fact that I know enough to know that, more surface area creates more friction, and in my mind, less friction is better if you're wanting something to move more easily. So
yeah.
I don't know, but with
I
the
agree. I
caveat
mean,
that either way, you need a little bit of lube on there. So
yeah, and I'm not saying anybody that does it is wrong or anybody that
no,
doesn't do it is right or any of that. I'm just, just my thoughts on it. I don't see it necessary for the knives I build, and that's pretty much it.
I honestly think it's one of those things that is such a slight difference that you couldn't really argue either way for or against it and
Yeah,
make a great case. You know what I mean? Like
yeah,
I
I
just
agree.
I think you could probably do a blind test of the exact same model of knife side by side, one with one flattened and one not, and probably not. Other than maybe if the first 50 times you open it or whatever. After that, I don't think you're going to feel any difference.
Yeah,
So just my opinion on it, but like, yeah, I just think it's kind of unnecessary.
yeah.
Not wrong, but not worth it.
Agreed. So, next question from Mr. Robert Iversen. And this one's, I guess, directed more at me, but I'd like to hear your thoughts on it as well. And he said, Chase, do you have a design that you go back to and everyone asks for as a custom knife maker that you may want to make as a production knife in a little higher volumes sometime in the future? And yes, probably my Cove model is the one I would go with. It's sort of a general size. It's about 3.3-inch blade or so, and it's doesn't seem to be too small for a lot of people. Doesn't seem to be too big. It seems to be kind of in that Goldilocks sort of zone. It's got some, I guess, stylistic flair. It's got a harpoon and a clip point blade. Sort of the things I like. I think it's the folder I've made the most of. I think I've almost, I don't know. I don't remember what number I'm up to now with it, but of like the single model, like it's definitely the highest one I've made so far. But yeah, if I had to go with one, it would probably be the Cove, and if not, I would probably go with the Mudlark folder, which I've only made two of at this point, or three of. But it's sort of more in that vein of like the Sabenza or the Mac 2, sort of a straightforward working knife. Actually, that's what this is a muddle arc, and it's sort of just a straightforward user with a little bit of design flair thrown in. And I think that sort of knife works well in a production sense. But yeah, so those would be the ones I would kind of go to at this particular moment. I would like to do that. I would like to be able to put stuff out in higher numbers, just not quite there yet. I hadn't been able to quite get the wheels turning yet. But
you're paying your dues. Throw
yeah,
back to a couple episodes ago.
something like that. Yeah.
Yeah.
But for you, I know like you're kind of returning back to a custom knife design now with the Dixon, but
Right.
like when we sort of started the production machining, or performance machine side of things, you sort of went with a brand new model with the
Right.
Mac 2. But
Yep.
what are your thoughts on sort of that?
Yeah. Yeah, I've definitely kind of reached the point now where I don't really know, honestly. I don't really remember my thought process totally when I got ready to do the Mac 2, and which was when we were getting ready to do something for production. I don't really remember my full thought process of why I thought I needed a totally new design to do that. I still am glad I did, and I kind of think it was the right thing to do. But I wanted, kind of like you said there, like, I mean, I like the designs that I had, but I thought when I wanted to make a production model, I was like, okay, if I'm going to put out something, I'm going to put out at, larger volume, then I want it to be something that's not too plain, but like a good solid working knife that had kind of classic lines that could maybe eventually turn into a classic. Just
Yeah, you don't want to be
just a
too
good
alienating as far as design
right.
if you're trying to hit a mass market.
Right, exactly. So that was, I made the decision just design something from the ground up. And two, it was kind of, I mean, I just kind of wanted that design challenge of coming up with what I thought was, because I designed other stuff, but it was kind of less thought put into it, I guess, like with some of the other models, as far as like, you know, the Dixon, I designed it because I was wanting to make a knife with a spider hole, and I kind of designed it around the spider hole. And then I mean, some of the other ones, like the Sodbuster, I wanted to make something, my version of that classic, the Sodbuster pattern or whatever. Like, there's just, my original folder design, the FMUC, was I wanted a folding version of the little fixed blade that I made at the time. That was like my first fixed blade model.
Yeah.
So I wasn't really set out to be like, okay, let me hit this specific niche in the market or whatever and design around that. It was kind of just, I just taken the design inspiration from wherever, just whatever hit me at the moment. So I kind of wanted to be a little more deliberate with this and be like, okay, this is going to be a production knife that I want to be, a lot of people to be pleased with, a lot of people to want to buy them, a lot of people want to continue buying them for a long time, be happy with them for a long time, actually carry them and use them, that kind of stuff. So I think that's kind of how I landed on something completely new. But then that being said, now with the second model with the Dixon, I was kind of like, okay, we've done that. So now, now I kind of feel like I want to do a little throwback to other models. Plus, over the years, we've had people ask and stuff, and so it's like, I know there was some demand for it there. So, that was fun. That was cool. I'm not really sure on the next one. We've definitely got a couple of models. The couple that I just mentioned, honestly, I've had several requests lately about the FMUC.
Yeah.
We'll see. Part of that is going to depend on how the market trends. If it keeps trending back towards bigger, bulkier knives, then the FMUC for sure, a revised version of it may make an appearance. We'll see.
I'd like to see what you do with an FMUC, like sort of
Now
going back and revisiting the design and seeing like how it evolves. Like, because that's always a fun part.
Curious.
Sorry, go ahead.
Yeah, no, I'm kind of curious about the same thing, and to see if I can make it so that I'm happier with it now than I was then. Because, like I said, that was my very first design, and like the biggest thing that bugs me about it is the blade to handle ratio. So I'd have to see if I can revisit it and see if I can make that at least. I don't know that I'd ever get it without changing it enough to completely make it a different knife. I don't know that I can make it as good a blade to handle ratio as the Mac 2 or even the Dixon, but maybe I can get it more to my liking at least. But what it made up for, or what it lacked in blade to handle ratio, it made up for in bulk and just brute strength though. So, and those things are so fun to open. Like they sound like a freaking bank vault when they open and lock.
They
It's
do.
just chunk. It is just cool to. I feel like it's almost like the knife version of like shooting a Barrett 50 cal or something. It's just like chunk.
Yeah.
Like, it's a cool sound and feeling when you open them and everything. But anyway, so like, yeah, that and maybe the side buster. Those are a couple that may eventually make a place in the lineup. We'll see.
Gotcha.
But then again, when I get ready to do something new, it may be. I've actually got one more that I'm thinking about too, or whatever. But I've had quite a few people actually. You mentioned the Tracker Jack earlier. It and the Killer Bee, or which most people know is the McBee.
Yeah.
The problem with those are that for whatever reason, people equate price with size, and it would cost probably within $20 of material wise. It would probably cost me within like $20 of the same amount to make a little McBee Killer Bee size knife as to make a Dixon, and people are not going to want to pay 20. I can already hear it now. If I put a knife that size out that's in the even say $500 range, say it's priced a little bit under the Mac 2, like people are going to oh my god, it's a tiny little knife, why is it so expensive? Like, they don't understand that almost all of the expense comes from the manufacturing process and like the handwork and stuff. It's not material cost. Material cost is a very low percentage of the actual cost of making a knife. So I don't foresee that changing anytime soon. I don't foresee people understanding that enough to be able to make a small knife like that the way if we get to the point where we've got things dialed to where we can literally make them cheaper because our processes are so good or whatever, or we have machines, or we end up with some robotics or whatever that can help to bring the manufacturing costs down, then maybe. But with our current method, there's no way I can put it out at a price point that people would actually be willing to pay. So that ain't gonna happen.
And on, I guess, that similar sort of note, Mr. Iversen had also asked a question about y'all making a G10 sided S35VN Mac 2 at a lower price point and trying to get it out to a wider market. But like you just said, that was sort of the reason I hadn't brought it up on the podcast. It was just
that's a good time to dive into it real quick for not going too long. Same principles, Rob. So like, yes, G10 is cheaper than titanium, but not by that much. I mean, you're talking about maybe, again, probably less than $20 in the cost of the knife by the time you make the G10 versus making the titanium. It might save a little bit more than that because the G10, we don't have it water jet cut, but at the same time, that means we're cutting it on the machine, which means it takes up more of our machine time.
Yeah.
It's messy. You got to do cleanup and stuff afterwards, which takes up. So you save some time on the machining because it machines easier and faster than titanium, but then you also have way more cleanup and stuff than with titanium, and it wears and tears on your machines a lot more because it's basically fiberglass dust in your machines. The steel going from MagnaCut to say S35VN would make almost no difference. The cost difference, unless you're talking about like Damascus and you're getting into like really the fancy dress materials. The difference in maybe if you talked about like a difference in like if we were using like
1095 to MagnaCut, maybe a difference.
1095 to MagnaCut would be enough to break, but even then you're talking about probably if you break it down to a per knife cost thing, you're probably looking at like $30 savings or something like that. You're not saving like a couple $100 by using G10 and a slightly less expensive steel. It's just not. I mean, that's not where most of the costs lie. So the material is, again, until you get into the really fancy materials, just with basic, and I'm talking the steels, like I said, unless it's like Damascus or something, the difference between the very most basic steel like 1095 or something like that versus or one versus MagnaCut is just not that much per knife. It's just not that big of a difference in price. So, and the machining, properties and stuff are not different enough to really. It's not like we're using a ton less tooling or anything like that. So, it just doesn't change that much. Honestly, it really doesn't. I need to look and figure out the math of what it would actually cost material wise. The difference in a a titanium show side versus a G10 show side, just strictly the material. I'll have to see if I can figure that up, but it wouldn't be. I can guarantee you it wouldn't be, just because I know how much the titanium show side by itself costs. Like, you're not, it's for sure not going to be more than probably $20-$30 difference, probably less than that.
Yeah.
So that's just not where most of the cost comes from. So it's the machining time and the machines to do the machining with, the payroll of all the people that put hands on it and work on it, all that stuff. So it's just not that much savings there as you would think that there would be.
Yeah. I mean, I think people think that because that's what a lot of the Chinese companies do. They'll put M3 and titanium on a knife and sell it for, $450, and then sell one for $250 that has G10 and S30. The thing is that $451, they're just straight profiting off of you. They're not really
right.
It doesn't actually cost them that much more, but
right, exactly. It's not costing them an extra $150 or $200 to make it. They just know that they can charge more for it because everybody wants Magna Cut and titanium. You're exactly right. That's the point. Most of the cost differences that you see in knives are just because it goes back to what I was saying, like you said. So I made this a really good tie into the size thing, because just like the size thing, most people, they know that the market is not going to, accept the same prices for G10 and a steel that's technically still a great steel and probably costs almost the same. I haven't priced S35VN lately, but I guarantee you it's not much different than Magna Cut.
Oh, it's close. Yeah, it's not far off at all.
The only caveat to that would be if you have a steel that for whatever reason that gets really hard to get or something, and they maybe jack the price up on it just because it's hard to find or something. But supply and demand. But for the most part, for a normal price for Magna Cut and normal price for S35VN, like, I don't know off the top of my head, so don't quote me on this, but I'd be willing to bet it's probably for the amount of material that goes into one knife blade, it's probably $5 difference, maybe.
Yeah, down to that level, I don't know if it's even that much.
You break it down.
You can't really.
You look at a whole sheet of it, it may be a couple $100 difference, but by the time you divide it out over how many blades you get out of that sheet, you're looking at maybe like $5 difference per knife. So the extra you see being charged because they're making it out of titanium and Magna Cut versus G10 and S35 is because they know the market will bear it, not because it actually costs them that much more. So just like I know the market won't bear a $500 knife the size of a McBee, even though it's going to cost me within probably easily within $50 of the same amount, to manufacture it as a Mac 2. But I know the market won't bear it, so I'm not going to do it.
Yeah. Again, back to that appeal, and like also that plays in. Not everybody's going to be as interested in a smaller knife, and there's also that perception. So, all right. Well,
good question though. I'm glad, really glad you brought that up. We may elaborate on it more down the road, and if you guys have more,
I guess I knew the answer to it, and so I wasn't thinking, in terms of bringing it to everybody else's attention.
Yeah, that was a good time to bring it in though, because it does correlate very well to the size thing. All of that stuff kind of is the same, in the same boat as far as how much difference it makes on the price and stuff. So
yeah. Well, all right. Like I said, we will have to hit lock interface and lock geometry and all the stuff that goes into locks at another time. But had a good discussion about detents, I believe.
Yeah, I think so too. I think hopefully it was something that was enlightening and informative to people and made sense. Like I said,
hopefully it made sense.
Yeah. Did you actually use your, because again, folks, just a reminder, I can't see Chase while we're recording these. So I'm just going to ask him, did you use some visual aids when you were talking about it? A little bit.
Yeah. Especially when you were talking, I was over here pointing at stuff on a piece of paper, and that way
you were being my Vanna White.
Yeah. I try to do that when you're talking. I hold up knives and point at stuff. Like when you were talking about lock relief, I was sitting here pointing and flipping it over.
That's awesome. Probably a good thing I couldn't see, because I probably would have cracked up.
That is
all
the
right. So part. Those of you that are, if you're on audio, good reason to come out and just just deal with having a look at our ugly mugs while you watch the video or whatever. But come over to YouTube and check it out. Maybe you can maybe it'll make a little bit more sense to you. So
watch me do silly things.
Yeah, we'll hit up on. We'll probably go ahead, unless some other urgent topic comes up. We'll probably try to jump into the lock face stuff next week and go from there. So if you guys have any more in-depth stuff about any of that or whatever, or stuff you want to elaborate on from this episode, then hit us up with that. But otherwise, we greatly appreciate you guys listening and or watching, and we hope you'll keep on. And please share the show out to people, guys. We want to keep growing this, and we're constantly amazed at how many people actually listen to us. But we always want more too. It's just going to make the show better and allow us to get more interaction with people and get some discussions and things that we all maybe want to hear about or whatever. So please keep those coming. So Chase is going to give you the email address where you can send some of that stuff in.
Yep. knifefreakshow@gmail.com. That is with one S. knifefreakshow@gmail.com. Hit us there. We are on Facebook, McNees Knives on Facebook and Instagram, Boatright Blade Works on Facebook and Instagram, McNeesknives.com, BoatRightBladeWorks.BigCartel.com. And don't forget those shirts still up there. The KFS Knife Freak Show NWO sort of design we've still got some of those available. And you got anything else?
That's it. We appreciate you guys, and we'll talk some locks next week.
Lock and load. Let your freak flag fly.